Alright, so in this particular lab, I am going to explain how to conduct propensity score analysis in the context of survey data analysis. So in the literature, there are some different opinions about how to fit propensity score analysis in the complex survey data context, and in this particular lab I will be focusing on that particular aspect, how to fit propensity score model from a propensity score matching approach in the survey data analysis context. Alright, so let's work with the data first. So this is a dataset from NHANES 2017-18, and I have downloaded the dataset. There are many other variables, but I'm just going to consider a few variables that are of interest for the current analysis, and I also have a few other variables that are the survey features that are incorporated in this particular dataset. So in general, I have more than 9,000 subjects, and I can take a look at the data and I can see some of the variables are character variables, some of the variables are labeled as integer variable, and some of the variables are labeled as character and factor variables, right? So one of the points that we have seen earlier is that for age variable, when age 80 is not really the age 80, it is a code that means 80 or 80 plus. So in that case, categorization of age might be necessary, but for the purposes of this particular example, we are not going to go into such detail. So this is a subsetted dataset in the sense that we are subsetting the dataset with respect to the covariates that we need in our analysis, and we are not really going to think about the other covariates. So that brings us down to only 14 covariates to worry about, and these are the name of the variables, and there are some other administrative variables or survey related variables that we have. In terms of the missing values, we can see the BMI, income, they have moderate missing values. On the other hand, the cholesterol, age, married, or education, they have a lot more missing values, right? So before doing any analysis, obviously we want to do some data cleaning and recoding, and one of the things that were mentioned in the earlier lab is that we have a weight variable, but the package that we are going to use, match it package, that automatically creates a weights variable. So later on it might be confusing to you which is the survey weight variable that you need to use, and for that I highly recommend you to name it survey weight or something appropriate that you can remember later, and delete the original weight survey weight variable that you had. In here I'm just defining the cholesterol variable as the binary variable. I am also recording the say for example diabetes is the exposure variable in our case, and I'm recording it to 1 and 0. Same thing I have done for the cholesterol as well, right? And the reason I'm doing it, instead of keeping it healthy, unhealthy, and diabetes yes or no, I'm keeping it at a numerical level, because that I will need when I will use some of the package such as matching package that I will use. Then the outcome variable has to be a numeric variable. So for that reason I am just going to define it as numeric at the beginning of the analysis. We will also do some subsetting, and for that we need to define the ID variable, and there are some other variables that we need to convert to factor variables or numeric variables, so that we do not have issue later. Also, the income variable is a multi-category variable. It is probably a good idea to order it so that this is the ordered categorical variable. If it is not ordered categorical variable, Then say for example color names like red, yellow, blue, those could be unordered variable, but something like income, it should be somewhat ordered. Alright, so we have 15 strata. We have 2 clusters within each strata, and this is very important to understand that say for example within this 15 strata, say for example for this particular strata there are 2 PSU, and in this particular strata there are again 2 PSUs, but these 2 PSUs that we have under this strata will not be the same as the PSUs we will have under this particular strata. So remember this 2 PSU per strata, so that means in total we have 15 multiplied by 2, 30 PSUs, unique PSUs in total, right? And you can try to tabulate these two, but these do not have a lot of meaning because these 1 and 2 are different for each of these strata. We could try to impute the missing values, but that part we are not doing yet. We will cover that in the next week. So for now, as an example, let us just work with an analytic data first, and I will show you later how to incorporate these in the design stage, so that we are not working with a subset in the design stage, but we are also working on the main data set in the design stage. So that part I will be explaining a bit later. Alright, so the first suggestion about how to use propensity score matching in the survey data analysis context came from Zanutto. In 2006, it was not a simulation paper or a theoretical paper, it was just an application paper, and in that application paper what she suggested is that it is not necessary to use survey weighted estimator for propensity score model. That means when you are modeling the propensity scores, it is not necessary to work with design. It is only you can simply work with your data set that you have. So the analytic data that you just created, you can work with that when you are building your propensity score. So let's walk through this propensity score matching. So there are 4 steps in propensity score matching, and this is the first step where we define the formula. Here diabetes was our exposure variable, and these were our covariates, and we select the variable the model, and then we specify that model using our matchit package, where we specify that run a logistic regression model to estimate the propensity scores, use a nearest neighborhood approach, use the replacement equals false, use a particular caliper of 0.2, and use a pair matching, that means ratio equal to 1. And then you can extract the distance object from that matching, and you can see the summary of the propensity scores from 0 to 0.8. You can try to see the plot to check who was matched and who was not matched, and then you can check the histogram. So this is the propensity score histogram for the raw treated and raw control, and this is the propensity score for the matched treated versus the matched control. Look at these 2 histograms, these look pretty similar compared to these 2, right? So we are hoping that our propensity score is working well. You can also check some numerical numbers. You can also try to check how many was unmatched, because this was a 1-to-1 matching. We have exactly the same number of people in the treated group or in the control group. So in the first step we specified our model, and in the second step we have fitted our logistic regression model to get our propensity scores and match them using the nearest neighborhood approach. So in the step 3 we are going to check in terms of a predefined cut point whether our matching was successful or not, and we can do that just by checking the create table once SMDs and whether our SMDs were less than 0.2 or not. So notice that we are working with the analytic data. That means what? This is not the matched data. This is the original data, and in the original data we can see there was a SMD of 0.399. That means what? That means our data was not balanced. But when we worked with the matched data that we have created in our step 2, in here we have created the matched data in our step 2, and we are just checking our balance in the matched data, and you can see in all of these SMDs are less than 0.2, which was already a predefined number that we decided before doing this analysis. So I mean, obviously this was a successful matching. That's why our SMDs were less than 0.2, or even it is less than even 0.1 in all cases. So we could even be a bit more strict about our SMD, and this gives me the confidence that our matching was good. But what if our matching was not this good? Some of the SMDs were still greater than 0.2. So the general suggestion is to go back to the step 1 and try to think about whether, in terms of the continuous variables such as this BMI, whether there was any polynomial term that we could incorporate, whether there were any interaction terms that were biologically plausible. Say for example, did this married and income or income and education, are they creating some sort of interaction? And if that was the case, then we would want to include those interaction in the first step and then come back to the step 3 to check these SMDs. Often it is also possible to check the categorization of the covariates and try to make a different choice of the categorization. The objective would be again to come down to the reduced SMD. There are other choices that you can make. Say for example, in the step 2, when we were matching the propensity scores, we choose a pair matching, and historically it is known that pair matching is not the best option in terms of matching, in terms of reducing the imbalance. There are other options like 1 to n matching, when you are changing the ratio equal to say 3 or 5 or 10, and you can also use the with replacement, matching with replacement as well, but that would change the nature of how we calculate our outcome model, and that part was already discussed in the previous part of the lab. Alright, if nothing else works, as a last resort we can try to think of whether we want to include any covariates in our outcome modeling or not. But generally speaking, in the propensity score context, even though you have used a variable in the propensity score development, that does not mean that you have to leave that variable out of the outcome model. There are some suggestions in the literature that suggest to use the same covariates in the propensity score as well as the outcome modeling, and they are often known as double robust approach, and that can be also done. But in here, since we have a pretty good balance, we are going to use a crude model. But before doing the crude model, Zanutto, what she suggested is that it is important to incorporate survey design in both linear regression and propensity score analysis. Ignoring survey weight affects the estimate in the population level substantially. In here she was basically talking about the outcome modeling or the step 4 of the propensity score model. So we already know that we have, when we are dealing with the enhanced dataset, we have the weights, we have the strata, and we have the cluster, and we cannot subset the dataset before creating the design. It was okay to use that subset data to estimate the propensity scores and check balance because those are the sample characteristics. But if we are trying to make a population level interpretation from the effect that we estimate, we need to incorporate the design properly. So for making that design, here is something that I have done to check which of the observations in the matched dataset are in the total dataset, and then I am simply using the entire dataset to create the design, and then I'm subsetting the design with only the matched subjects, right? And then I'm ready to do the outcome analysis. And in this outcome analysis, I am just going to do a crude analysis. I'm going to use the outcome and the exposure to get the odds ratio, and the odds ratio is 1.62. We can also do the adjusted regression as we have mentioned. In that case, what we will do, we will use more variables as the adjustment variable after this exposure variable, right? Right, I'm not going to show this part, how to include more variables in the formula, because you can do that on your own. Alright, so this is not the only suggestion. There were few other suggestions in the literature of how to use propensity score analysis, and I'm going to discuss them in the next labs.